Hi, it's Jason here. Welcome to my fourth episode of my linked list series. And in this episode, I'll be telling you how to delete a node from the list. In the previous episode, we showed you how to insert a node in the list, and this is kind of like the counterpart. So the three functions that we'll be implementing here are delete head, which basically deletes a node from the start, delete end, which deletes a node at the end, and delete node, which is the general case which can delete a node at any position. So to test these three functions, I have written some tests in testlist.c. So these are the delete functions. The first part, we're just deleting the starting node. Our starting list for this was 1337 to 103 1000. So when we delete the starting node, we should be left with 2 103 1000. Next thing we're going to do is test our delete end function, so delete the last node, so we're left with 2 103. And finally what we're going to do is going to delete a node from position 1, so we're left with 2 103, position 2, so we're left with 2 and 100, and the tricky one is we're going to delete a node from position 0. So instead of using the delete head function, we're going to use the delete node function, and when we delete this part, we should be left with just the 100 in the list. So that's what we're doing in our list. So the first function we're going to write is delete head. To delete the head, it's fairly simple. We're just going to create two pointers, one that points to the old head and one that points to the new head. So this was the old head, and it's the one thing that we're going to delete, and another pointer to the new head, and we're going to call this new head. So that's the first step, just to find these two pointers, and it's not that hard. The second step, what we need to do is we need to take the old head, or rather take the list's head and make it bypass the old head. So we want to make this list, instead of pointing to the old head, make it point to the new one, so do this. And then the third thing we need to do once we've done that is to delete the old head. So before we delete the old head, we also need to delete the pointer first, and then we free the old head. So to write that in pseudocode, our first step is to find old head and new head. Our second step is to change the list head to point to new head. So set list head to new head, and then finally what we need to do is just delete the old head. So the step in grey. Okay, so let's do these steps one at a time. The first step, find old head and new head. So old head is literally the same thing as L arrow head, and new head is old head arrow next. So to implement that, we'll do this. Old head equals L arrow head, and we create another node pointer, and we've got a new head. We're going to make that point to old head arrow next, because the next node, the second node, is going to be the first head of our new list. Okay, so that's done. The second thing we need to do is set new list to the new head, and that's as simple as saying list arrow head, so this red arrow, set it to be new head, the same place where new head is pointing. So that's just literally list arrow head equals not list arrow head, L arrow head equals new head. Alright, and the first thing we need to do is just delete the old head. And like I said before, to delete the old head we need to do a couple of things. First, we need to null the pointer and then free the old head. So to null the pointer, we just say old head arrow next equals null, and then we want to free old head. Alright, so that should be that function. Oh, and before we do anything, we should also assert that we're not deleting from an empty list. So assert that the list is not empty, so we use the num_items function. L is greater than 0. Alright, so let's try that. And before we test that, we should comment out the test for delete node and delete end, because we haven't written those functions yet. So we want to comment out this. Alright, and let's do it. So gcc minus wall minus wherever minus big O minus little o, and we're going to call it list tester. And our two functions are, two C programs are list.c and test list.c. And it compiled, so let's just run list tester. And we can see our insert functions worked, and we're trying to delete the first thing, which is 1337, and we did. And it says all tests passed, you are awesome. Sweet. So we know that delete head works. Okay, let's try the second function, which is delete end. So we still haven't written delete node up to this point, but we can move this comment down here now. So basically the next thing we're trying to do is to try to get this section to pass. Let's try that. In our function delete end. To delete the end node of a list is a little bit trickier, but it's still not that tricky. Once again, we're going to want two nodes. The first node we're going to call the new end, because that's where the new end of the list is going to be once we delete the end of the list. And then we want another node to the old end, pointed to the old end. So we're just going to call that old end. Okay, so that's the first step, to find these two pointers. And the second step, which is pretty simple, is to set the new end to point to null. So new end points to null. And then the third step is simply just to delete the old end. So free this. Alright, so we'll write that in pseudocode. Our first step is to find new end and old end. Our second step is to set new end to point to null. So set new end node to point to null, and then the third step is simply to delete old end. Right, let's do that one at a time. So firstly, finding new end and old end. When we initialize these two, we're going to initialize it to point to these two nodes. So new end is going to point to the head, and old end is going to be new end arrow next. So let's do that. New end is L arrow head, so, and old end is the next node after that. It pointed to the next node after that, so new end arrow next. So that's just going to create two nodes here, but we want to shift these along. You want to keep shifting it along until old end arrow next is null. So that's our condition for terminating the while loop. So while old end arrow next does not equal to null, what we need to do is need to shift the new end forward and the old end forward. So in order to do that, we just go new end equals new end arrow next, and we do the same for the old end. Old end equals old end arrow next. And before I do anything, I should just put this assert in here as well. We want to make sure we don't delete anything from an empty list. So, alright. So that's that step. The next thing we need to do is set the new end pointer to null. So we basically want to create this red arrow here, and that's pretty simple. It's just we wrote new end arrow next equals null. Alright, and the last thing we need to do is delete the old end. So we want to get rid of this node, We don't have to null this pointer because it already points to null, but we do have to free it. So we just go free old end. Alright, so let's try that and make sure that this compiles. Let's see. Okay, didn't quite work. Error, new end undeclared, old end undeclared. Okay, that's pretty silly of me. I should have said node pointer because we need to know what type it is, and the type is a node pointer. Alright, so let's try again. This test. Alright, and we can see that once we've deleted the 1337, we're trying to delete this 1000, and we have done so. So all tests passed, you are awesome. In other words, our delete end function works. Now for the tricky one. The delete node function, which can delete from any position. We don't need these comments anymore. Alright. Delete node is going to be a bit trickier, but the basic principle is the same. Once again, we're going to need two pointers. A pointer to the node that the node before the one we're going to delete. So if we're trying to delete this, the node at position 1, we need a pointer to the node at position 0. And we're going to call that node pointer before. And the second thing we're going to need is a node pointer to the thing we're trying to delete, and we're going to call that current. So if we're trying to delete the node at position 1, before would be at position 0, and current would be at position 1. So that's the first step. The second thing we need to do is to make this before bypass current. So before arrow next, we want it to point to the node after current. And the third thing we want to do is we want to delete this current node. And once again, before we delete the node, we must null the pointer too. Okay. So let's start with by writing that in pseudocode. So the first step is to define before and current. The second thing is to skip the current node, and the third thing is to delete the current. So let's start by finding before and current. We're going to want to do this in some sort of while loop, but at the start we're going to leave them pointing here. Yeah. So before is just going to point to L arrow head, and current is just going to be before arrow next. So we're going to have node pointer before equals L arrow head, and node pointer current equals before arrow next. Okay, so that's just going to point to the start, but we need to shift these pointers along some distance. So in this case, if we're trying to delete the node at position 1, well in fact we don't need to shift it forward at all. However, if we were trying to delete this node, the node at position 2, we would need to shift these forward 1. In other words, the number of times we need to shift it forward is the position that you're trying to delete minus 1. So in our while loop, what we'll have is we'll have something like this: int count equals 0, and while the count is less than position minus 1, because we want to repeat it n minus 1 times. And then whilst we're in this while loop, we want to shift before along using that same thing we did before. Before equals before arrow next. Do the same thing for current. Current equals current arrow next. And then, of course, increment the counter. Alright. So that's the first step. We found before and current. The second thing we need to do is set this red arrow to point to the node after current. In other words, this red arrow should point to the same thing as this black arrow. This black arrow is current arrow next. So we want before arrow next to equal current arrow next. Alright, so that's not too hard. Before arrow next equals current arrow next. And finally what we want to do is delete current. So we need to do two things. First, null this pointer, and secondly, free current. So to null the pointer, all we do is current arrow next equals null, and we need a free current. Alright, so fingers crossed, hope this works. Let's see. GCC. So it compiled, and it didn't work, and that doesn't surprise me. Okay, so let's have a look what happened here. So now we're deleting nodes. It was able to delete the 1 at position 1 to get to this 203. It was able to delete the end 1 at position 2, delete this 3, so we're left with 2 and 100. But when it tried to delete the node at position 0, instead of deleting the 100, the 2 rather, it deleted the 100. And that doesn't surprise me. And the reason why this is because if we're trying to delete the start of the list, we need to change the head, and we didn't do that. So there is a special case that we need to consider when we are trying to delete a node at the start of the list. And when this is the case, we just need one pointer, a pointer current here. And we don't need to worry about the before pointer, we can just null it if we want to. So first we just set current to be the head, and secondly we make the list head bypass current like this, and thirdly we just delete current. Okay, so we're going to have to add some if statements to our logic in order to account for this possibility that the position is 0. And in fact, we should probably do this too. Make sure we're not deleting from empty list. And we should also check that the position is valid. So position should be greater than or equal to 0. And also, position should be less than or equal to the number of items of the list. In fact, it should be strictly less than, because if there's 8 items in the list, the last item you can delete is the item at position 7. So we want to make sure that these are true. Alright, so this loop finds before and current if the node we want to delete is in the middle, this whole block. But sometimes that's not the case. So if position is greater than 0, then do all this stuff. Yep. So we'll just indent that. However, if it is equal to 0, we need to do something different. So in this case, when it's equal to 0, we don't even care about before, so we're just going to null that. We want current to be pointing to the same as the head. So if it's equals 0, before equals null, and current equals L arrow head. Yep, just leave that comment there. And the other thing we need to do is, if we're dealing with the case that we're deleting something from the start of the list, instead of changing the before to skip the current node, we need to change the head to skip the current node. So we need to change this red arrow which starts from the head instead. So we need to have an if statement here as well. If position is greater than 0, then do your normal thing, else do something else. Else, and this happens if position equals 0. So if position equals 0, what we want to do instead is set the head to bypass current, or L arrow head equals current arrow next. Or in other words, this red arrow, assign it to that black arrow. So L arrow head equals current arrow next. And then in both cases, we delete the current node by nulling the pointer and freeing the current. So hopefully this should fix our problem. Let's have a look. GCC, before undeclared. So let's go to line 174. Apparently before it's undeclared, eh? Oh, this is bad practice. We shouldn't write that here because we entered it here. What we should do is declare them both here outside the if statement. Before and node pointer current, because we know that we're going to initialize them somewhere in the if statement. So now let's try it. Compiles, and we can see all tests passed, you're awesome, and at the end we're left with that solitary 100. Nice. So that is a demonstration of how you would delete nodes in a linked list. So in these past 4 videos I've covered how to implement the linked list data structure in C, how to implement basic getter functions in the second video. The third video showed you how to insert nodes, and the fourth one showed you how to delete nodes. I believe these are the most fundamental interface functions that you'll probably need to implement. If there is enough demand for it, I will do more complicated ones such as reversing a list or maybe interleaving 2 lists. But before then, see you next time, and thanks for watching.